Topological sorting can be achieved using the already implemented DFS algorithm, or it can be achieved without using DFS algorithm. First, we'll see the implementation using the DFS algorithm. Again, when I'm talking about topological sort, I am talking about directed and acyclic graphs only. Topological sort will be applicable only to directed acyclic graphs. They are used for topological sorts, and when I'm talking about topological sort of such a graph, it is a linear ordering of the nodes u, v, which are belonging to the set of vertices v of the graph, such that if uv is an edge in the graph, if uv is an edge in the graph, then u appears before v in the ordering. That means if there is an edge from u to v, then in the ordering u appears before v. तो ये एक linear ordering है. For all the edges, this will be holding true. And if there is a cycle in the graph, then no such ordering will be possible क्योंकि u to v भी होगा, v to u भी होगा. In that case, linear ordering would not be possible. So what is a topological sort? It is a linear ordering of the nodes such that if there is an edge from u to v in the graph, then u will appear before v in the ordering. This is simply known as a topological sort, and this is only applicable to directed acyclic graphs. Are you all able to understand what I'm trying to say?
Yes, ma'am.
So using DFS, topological sort can be finished only in 3 steps. It's very simple. To achieve topological sort using a DFS algorithm, supposedly I'm having some topological sorting algorithm on the graph G. In this algorithm, I need to call DFS on my graph. I am calling the DFS on the entire graph, and I compute the discovery time and finish time for each vertex. And the thing which I'm interested in here is the finish time. Compute finish time for all vertices belonging to the set of vertices in my graph. Now for each vertex, whenever each vertex is finished, you are going to insert it in a linked list. So the next step is when a vertex is finished, जब वो finish होगा, जिस भी order में finish होगा, insert it in front of a linked list. We'll see this with an example. I'm just writing down the algorithm. Insert in the front of a linked list, and finally is return the list. जो भी आपकी लिंक लिस्ट है, that is the order. Finally return the linked list. जिस order में वो linked है, that is your topological sorted array. I hope the steps are very clear.
Yes, ma'am.
If you look at the complexity of the algorithm, DFS will take of the order v plus e time. We already have seen this, that the complexity of DFS algorithm is of the order v plus e time. Then after we are finishing, when I'm inserting an element in the front of a linked list, it will take some constant time only. फ्रंट में हर
Yes,
बार
ma'am.
इंसर्ट करने के लिए it will only take a constant time. जितनी भी लिस्ट बड़ी हो does not make a difference. I am inserting in the front. 3 steps will be there. It will be taking constant time. Returning the list will again be taking the constant time. So if I am adding these, topological sort using DFS can be implemented in the order v plus e running time. Is the complexity of the algorithm clear to all? Should we just see an example and see what do we mean by the topological sorting?
Yes, ma'am, it is clear.
So let's move on to a simple example to see what is happening and how are we creating the list. or how are we topologically sorting using DFS. So DFS is a depth first search algorithm, but the finish time of DFS has many applications. Another application will be strongly connected components. We'll just see that also. Again, I have to take a directed acyclic graph. So you please be sure that whatever graph we are having, it is a directed and acyclic graph. So I'm just taking an example here. And we will be performing the DFS. I'll just increase the size of the node so that I can write the start and finish time. And then I will be drawing the nodes. So we have now, in case I am having that this is connecting to this is connecting to this, and this is in case it is a cycle, topological sorting is not possible. So I will not be doing that. In case it's a cycle, topological sorting is not possible. Please make sure that it is not a cycle. So this is my given graph supposedly, and as you can see, there is no cycle existing in the graph. It's a directed acyclic graph. Now to perform topological sorting, what do I mean by that is, since there is an edge A to B, A to E, A to D, so whatever is my ordering, A will come before B, E, D. Since there is an edge from B to E, B will come before E. Since there is an edge from D to E, D will come before E. Is the point clear? I do hope I'm making sense. If you see that if I am having such an now there is an edge from C to E also, that means C will also come before E. So C should come before E, and there is an edge from E to F, so it should come before F. So technically, this could be one possible topological linear ordering looking at the graph. Are you all able to get this? Excuse me. कुछ समझ आ रहा है?
Yes, ma'am.
So let's see how do we do this using DFS algorithm now. So implement करने के लिए, when we will be implementing this, what you have to do is, now here you are beginning with supposedly a node. So you are beginning with the start time 1. After discovering a node, you have to go to the adjacent nodes. You can go to any adjacent node. Supposedly you go here, you discover B. From B, you discover supposedly E. From E, you are discovering F. And from F, you cannot discover anything back. So you will be finishing F. Now, when you are finishing F, then now this is a linked list that I am taking here. Now within this linked list, I am inserting in front. I am writing it here because this is an empty list right now. So I start inserting like this. So I am inserting F. This is my front of the abhi empty list hai, so there is only a single element F. Now I come back to E. There are no more adjacent nodes of E. I will be finishing E. Now I insert E in the front of the list. So this becomes my list. I hope I'm making sense. To insert E in the list, what will I do? If this was the start of the list, I will replace the start with E and I will make E point to the start. Yes or no?
Yes, ma'am.
I hope this everybody can implement on their own, or do I need to give you the steps?
Ma'am, we can implement.
So after E is finished, you go back to B. There is one more node adjacent to B, which is C, which is still undiscovered. So you start C. There is no more adjacent nodes of C, so C is finished. So you insert C, start moves again here. So C will now become the start node. You go back now, there is no more node adjacent to B. So B is also finished here. You insert B and start moves to B. This becomes your list. This becomes the start. And you come back to A. There is one more node adjacent to A, which is discovered. No more node adjacent to D, which is left. So D is also inserted, finished, and inserted in the front of the list. Finally, A is finished and it is inserted in the front of the list. So we have finally got the topologically sorted list using DFS algorithm. I am performing DFS according to the finish time of the algorithm. Whichever is finishing first, that I am inserting in the list and then I am moving. Is this clear to all?
Yes, ma'am.
Anybody who has any doubt in the topological sorting using DFS algorithm?
No,
There
ma'am.
is another method of performing a topological sort without using DFS algorithm. You all know what is the degree of a graph? What is the degree of a graph? Of a node, sorry. Just for example, if I'm talking about degree, what is the degree of B here? All of you understand degrees of the nodes or not?
Ma'am, in degree or out degree?
Thank you so much. You do understand. What is the in degree of B?
1.
1. And what is the out degree of B?
2.
There are
2.
two edges going out from B, so the out degree of B is 2. There is one edge coming into B, so in degree is 1. I hope this is clear to all of you. Now what we want to do is to perform a topological sort without DFS algorithm. We are repeatedly finding a vertex of in degree 0 and we'll be removing it from the graph and all the outgoing edges from the graph. So what we try to do is we begin with a node which has in degree 0. उस node को we will put first in the topological sort. उसकी जितनी outgoing edges है उनको remove कर देंगे. फिर जो ग्राफ बचेगा उसमें से फिर से रिपीटेडली इन डिग्री 0 वाले नोड्स यूज कर फाइंड करेंगे. What I mean to say is supposedly इस पे DFS वगैरह कुछ implemented नहीं है. You have in degrees of all the nodes here. Which is the only node having an in degree 0 here?
A.
A.
A is the only node having an in degree 0 here. तो A को आपने लिस्ट में इंसर्ट कर दिया. A के जितने भी आउट एजेस हैं उनको डिलीट कर दिया. Now this is the left of the graph. आपने A को ग्राफ से हटा दिया और उसकी सारी outgoing edges को भी हटा दिया. This is what you are now left with the graph. Now within the left over graph, how many nodes are there within degree 0?
B.
Ma'am,
B.
B.
B and D. There are two nodes
D.
within degree 0. You can choose either.
No, D.
So supposedly you are choosing B. You insert it. You remove this also from the graph and you remove the outgoing edges from this node also. Again, you see which are the nodes within degree 0. So you will have to come outgoing edges sari remove. So you could either pick C or you could pick D. Supposedly you are picking C here. So again, remove this node from the graph and the outgoing edges from this particular node. Now choose the node within degree 0. There is only, how many nodes are there within degree 0 now? There is only one node D which is within degree 0. E or F की in degree 0 नहीं है ना? So you will be choosing D. Remove this, remove the outgoing edge. Choose E because that is the only node within degree 0. Remove this, remove the outgoing edge. Finally remove F. So now you are left with empty graph and what you have got is again a topological sort. Have you all understood this? The concept, the idea which I am trying to put forward for doing the same thing is clear to all?
Yes, ma'am.
So this we have achieved without using any DFS or anything. So what we want is that this idea concept is, I suppose, clear to all of you. I want to implement this idea in the same running time or less. Same or less. क्योंकि उससे ज़्यादा में तो I would not want to run it ना. So I want to devise the algorithm to implement whatever idea I've told. Idea is only to find the nodes, repeatedly find the nodes within degree 0 remove them from the graph and remove the outgoing edges of them from the graph, and just continue doing this till there is any node left in the graph. This I want to implement in the form of an algorithm which is not going to take running time more than of the order v plus e, which we have already achieved for solving the same problem using the DFS. Is it clear? A yes or no?
Yes, ma'am.
Can you all try this? Algorithm, obviously I will give, but I want you all to just try this. Will you all try to write the algorithm?
Yes, ma'am. We can try.
So shall I leave this as a homework for Saturday, Sunday? By Monday, you all will send me the algorithm that you write. Please do not go to internet and copy. That is not something I'm looking at. You give me incorrect algorithms, I will be very happy. The only thing is you should try yourself to write the algorithm. Otherwise, you will never in life be able to write algorithms for the problem. You know the solution, you know the problem. इसे सिर्फ mathematical terms and computational terms में you have to write. So try implementing this without using any internet help, please. And even if it is wrong or correct, just send me the algorithm. I am more than happy to see any incorrect algorithm also. Trust me, the effort is all that matters. So I leave the implementation part for you all to try. I'll give you the answer that I'm having, but I want you all to try one. So let's move on to the next. Is the problem and solution clear to all? The only catch here is I believe that all of you can do this very easily. If you are having a graph using an adjacency list or an adjacency matrix, you just have to run some loops. The only catch is to make sure that the running time of the algorithm is of the order v plus e. Fine. So thank you so much for all saying yes. You all just try this and just give me the algorithm. Try to make the running time in this order. Otherwise, how do we make the running time like this? We'll see that also. So whatever algorithm you can write, even if it is taking more time, do write the algorithm and do send me. So let's move